Good morning everybody, and thank you for joining this webinar where I will give you an overview of the Geotools software. First of all, why Geotools? Geotools is a software for analysis, modeling and interpretation of multiphysics data. These data, like MT data or TDM, are often used in the geothermal field for subsurface imaging. Users can load in Geotools databases several data types, like MT data, TDM data, or ancillary information, and in the software we'll find a full set of tools for analysis and 1D, 2D, and 3D modeling. Data and modeling results review can be done station by station in sounding mode or in map and section views. Geotools offers a dynamic and integrated workspace. In a database can be loaded MT data together with ancillary information, profiles, models. In the same database, users can generate and save documents. Documents are maps and sections and are multi-property objects that can be used for data analysis and for inversion results review. Views can be arranged in order to see more than one window at the same time. All the database content is synchronized. This means that a modification applied to an object in the database is then immediately reflected in all the compatible documents. In this case, moving of a profile corresponds to an update of the section shown below. All the documents and elements of the database are easily accessible by users. As example, soundings both from MT and TDM data can be easily opened from map. MT data analysis can be done station by station in sounding window mode, or can be done on entire MT datasets extracting property grids and parameter plots in maps and along sections. MT soundings can be quickly opened directly in map with a double click on a station location. In data analysis work session, users will find all the tools necessary for data editing and rotation. Modifications applied can be saved in the database, and the reopening of a sounding allows for more editing or for a review of the editing just done. Users can quickly generate property layers from their MT datasets in maps and also along sections. Layers are totally under user control that can change their appearance in terms of color scale, contour options, extraction options. These are dynamic layers, meaning that it is enough to change the extraction options to have an update of the layer. Changing extraction periods is possible to have an overview of the behavior of the entire dataset on the frequency bandwidth acquired. Data grids can be extracted also along profiles. As we have seen for maps, users can control the appearance of these layers in terms of gridding parameters, for example. For all documents are available also plot options. In this way, users can arrange their documents that can be then saved, for example, as JPEG images. All objects are synchronized in the database, and soundings can be opened both from a map and section. Editing done on a sounding is then immediately reflected once saved in all the open and compatible documents. With the 1D MT modeling tools, users will be able to calculate layered and smooth 1D models for their MT data, and modeling results can be reviewed in map and along sections. Data misfit can be analyzed station by station in sounding mode, or in section and maps generating normalized plots that allow for comparison between observed and calculated data. MT soundings can be opened in 1D modeling mode directly from map. Observed data can be T, TM, or invariant component. In the sounding window, together with the observed data, are shown continuous lines representing the synthetic response to the model shown on the right. These responses are immediately updated when a change is applied to the models. This means that the 1D modeling tool can be used also for quick sensitivity studies. 1D modeling can be done station by station or on more than one station using the batch tools. Once users have their 1D modeling results, grids can be extracted from this model both in map and section. As we have seen for the MT data, these layers are totally under control by the user, as well as plot options of the various documents. When layers are sharing the same unit, the color scale can be simply copy-pasted from one to the other. 1D models can be opened from any document, updated in case of need, and the modifications applied to the model are then immediately reflected in all the compatible documents. Together with MT data can be loaded in Geotools also loop time domain EM data. For this data we have similar tools to what we have seen until now for MT, so data analysis tools and 1D modeling tools. TDM data are usually acquired together with MT data in order to have a tool for the correction of the galvanic distortion that may affect the MT data. Users in Geotools can calculate 1D models from TDM data, getting a good representation of the very shallow resistivity. Then this data can be associated with MT stations, and in MT sounding analysis, as we see in the example in the top right image, users can plot as a black line the MT response corresponding to the 1D resistivity models from TDM data, and use that line as a reference for the application of a static shift correction. Users can import in Geotools also other data types, like for example horizon grids, digital elevation models, point and grid data, like GraphMag data, or wells and point sets with attributes that can be gridded in maps and along sections. 2D and 3D models can be imported from external files or can be generated in Geotools using the available tools. Images can be imported as well and can be georeferenced or not and displayed in map or along sections. There are also some other tools available for users, like for example the picking points tool, that allows for the selection of points in map, section, or directly from the 3D modeling module, as we will see in the next slides. Starting just from survey layout in case of a synthetic study or from real MT data, Geotools users with the 2D MT modeling module will be able to set up their starting resistivity models and run 2D MT forward and inversion calculations directly on their computers. 2D models are multi-property objects, meaning that for one mesh geometry it's possible to generate and save in the database more than one resistivity property. These models can be simple uniform models, layered horizon-based models, or even more complex models. Once starting model and station locations and data are ready, then users can proceed with the calculation of 2D MT forward response or with the calculation of an entire inversion. At every iteration, users will see modifications applied to the model directly on their screen, and at the end of the inversion will be saved the modeling results together with the inversion parameters and statistics, and also synthetic data that will be available for analysis and comparison with observed data in sounding mode and along sections and maps, generating normalized plots. In this example, starting from a uniform model, we are going to run a 2D MT inversion. After having defined the starting model, it's then necessary to define the inversion parameters and establish the maximum number of iterations to be run. Then, clicking on OK, the inversion starts. As anticipated, at every iteration, the resistivity model is immediately updated. Since 2D models are multi-property objects, users can run more than one inversion and save the results in their 2D model. For example, they can, after having run an inversion, change the inversion parameters and make a restart. Or they can go back to the starting model definition, change it and run new inversion, or just starting from the same starting model, adjust the parameters and run a new inversion. For every result that is saved, are saved in the database the resistivity model and the synthetic data. Double-click on a sounding directly from the 2D modeling tool opens it in the sounding mode, showing comparison between observed and synthetic data. With the 2D survey design tool, starting from profile, users can create their own station layout and then, using the 2D MT modeling module, proceed with the forward studies. Once the stations are projected along the profile, in few clicks, users will be able to generate their own resistivity models. The first model is guessed by Geotools based on profile and station layout geometry, but geometry and resistivity of this model are totally under user control, that can change them whenever it's necessary. In this example, we are going to create two models. The first one is a uniform 100 ohm meter model, and then we will generate a layered horizon-based model using two horizons that were previously imported in the database. Once the model will be saved in the database, we will then proceed with the calculation of the forward responses to these two resistivity models. To do that, it's just enough to switch to the 2D inversion step, recall each model, and run the forward calculation. Synthetic data will be saved in the database and available for comparison and also for export to external files. MT surveys are multi-property objects, meaning that for one station location, users can save not only the observed data, but also a series of synthetic data coming from 1D, 2D, and also 3D forward calculation. Recently, this summer, we have introduced a new module to the Geotools platform, that is the 3D MT forward module. Users can start from their own survey design or define the survey design directly in the software, and then proceed with the generation of the 3D mesh, defining its geometry and resistivity filling, and with the calculation of the 3D MT forward responses. The calculation is done on the user computer, and runtime for 16 frequencies and 1 million cells model is around 6 minutes on a model computer. In this example, we are going to see a 3D forward study starting from the definition of a survey design. Stations can be deployed along regular grids or just picked in map as sparse points. They can be saved to an MT survey and then used for the definition of a 3D mesh. To generate a new 3D mesh, it's necessary to define a survey and a topography grid, and then the mesh created is totally under control of the user, that can change its geometry in both horizontal and vertical direction, and can also define the resistivity filling in the model editing step. In this case, we are going to realize an horizon-based resistivity model using the horizon grids that we have used also before for the 2D modeling. Once the model has been defined, These can be inspected by the user in all the 3 directions using the model slicer. If any modification needs to be applied, this can be done using the property population table that we have just used, or using the painting and replace range tools that we have introduced in the latest software release. Once the model has been saved, we can proceed with the calculation of the forward response. It requires the definition of a few parameters like min-max frequency and point per decade, and then the calculation starts. 3D models are also in this case multiple property objects, so more than one property can be defined and more than one synthetic response can be calculated and saved in the database. Recently, we have improved the picking points tool available in Geotools. Picking of points can be done along sections, in maps, and also in the 3D MT modeling module. In this case, we have imported an external file, resistivity model, that we have then converted to a 3D modeling object. And we are now proceeding with the picking of the base of conductor along 3 sections. Picking of points can be done, in this case, in every direction and even in every model slice. The picked points can be saved to a point set and then shown in map for generating an horizon out of these points. The horizon generated can be then saved as an external file or can be saved as a database object, like we are going to do, in order to then be able to use this horizon for further interpretation steps or also for modeling, since it can be used as an horizon for setting up of new 2D and 3D models. On the CGG Cloud are already available the 3D MT Inversion tools that we license to our clients. These tools, combined with Geotools, offer a full package of software for MT data analysis, modeling, and interpretation. Users can work locally on their computers, analyzing the MT data and preparing them for the 3D inversion, and in Geotools can generate the starting resistivity model. These objects can be then exported from the Geotools database to external files and uploaded to the CGG Cloud. On the CGG Cloud, there are all the tools necessary for running the 3D inversion. The 3D MT inversion uses the RLM 3D code. After having started an inversion, users can have a preview of the inversion results by web browser. Once the inversion has finished, results can be downloaded and imported in Geotools for model review and data fit analysis.
Thanks for your attention. For any question and for receiving more information regarding the software, please contact us by email.